Today's tech news moves fast, but understanding it shouldn't be hard. That's why Snarful Solutions Group brings you Connecting the Dots, where we break down what's happening in tech and why it matters to you. Now, let's dive in with your hosts.
Imagine an organizational chart where like 80% of your workforce isn't actually human.
Right, which sounds crazy.
It really does. We're talking about a company where software programs are independently monitoring inventory, spinning up marketing campaigns, and actively hiring other software programs to help them finish their assigned tasks.
It sounds totally like science fiction.
Yeah, exactly. But today, we are looking at the exact physical hardware and the new corporate platforms making that a reality. Welcome to Connecting the Dots, the show where we break down the day's top tech news and figure out exactly how it impacts your daily life. I'm Alex.
And I'm Morgan.
And it is Wednesday, April 22nd, 2026. We are broadcasting live from Snarful Solutions Group right here in Sacramento, California.
Beautiful Sacramento.
Always. Before we unpack the morning's news, let's take a quick look out the window and at the numbers. If you are heading out in Sacramento today, you might want to keep an umbrella handy in your car.
Yeah, definitely.
We've got a chance of showers and thunderstorms early on, followed by a slight chance later in the afternoon. Overall, it's going to be a mild high of 64 degrees Fahrenheit with some very light winds blowing around 6 miles per hour.
Honestly, it sounds like a perfect day to just stay inside and watch the markets, which gave us some serious turbulence yesterday.
No, for sure.
Yeah, looking at Tuesday's closes, it was a bit of a rough ride on the floor. The Dow dropped 538.99 points, closing at 49,149.38. And the S&P 500 also took a dip, shedding 58.63 points to close out at 7,064.01.
Context is everything, though. I mean, both of those indices are still up for the week.
Right.
So no one needs to, hit the panic button just yet. And if you happen to be holding crypto, you are having a completely different Wednesday morning.
Oh, totally different.
Yeah, we saw a massive juxtaposition today with the Bitcoin surge. It jumped over 2,133 points to close at 78,474.84. So depending on what is in your portfolio, you're either taking a deep breath or, popping champagne.
Very true. At least our local baseball teams brought some solid stability to the table on Tuesday.
Thank goodness for that.
Right. The SF Giants managed to beat the Dodgers 3-1, and down the bay, the Oakland A's took down the Mariners 5-2. It is always a good morning when both local teams pull through with a win.
Definitely. Well, it is time to unpack the Morningstar Tech Report. We've got a stack of stories today that really show how the fabric of our working lives is being rewoven by artificial intelligence.
It's a huge shift.
It is. But before we look closer at the physical engines driving all of this, let's hear from our sponsor.
Today's episode is brought to you by Strong Coffee, the premium instant coffee that tastes like a traditional brew, but is packed with 15 grams of protein, emphases, and adaptogens like ashwagandha. Get clean, sustained energy without the jitters. Use promo code SNARFL for 20% off at strongcoffeecompany.com.
Moving from the energy boost of our sponsor, we need to talk about the massive computational energy driving the next generation of tech.
The raw power.
It's exactly. To understand where our daily workplace tools are heading, we first have to step into the engine room. And right now, the biggest engine room in the world belongs to Google. They just unveiled their new 8th generation custom Tensor Processing Units, or TPUs.
Yeah, and this represents a massive architectural shift in how artificial intelligence is physically built. For years, the entire industry relied on a unified approach.
Like a one-size-fits-all kind of thing.
Right. You had a chip, and that chip had to do two distinct jobs. First, it had to train the AI model, which means crunching decades of human knowledge for months at a time.
Which takes incredible power.
Exactly. Then, once the model was trained, that same type of chip had to run the model answering user questions in real time. But with the rise of the agentic era, where AI programs aren't just giving you a text response, but actually executing multi-step workflows in continuous loops.
Doing actual tasks for you.
Yeah, that unified hardware was just hitting a wall.
So Google is doing something completely unprecedented here. They are physically splitting their AI silicon into two separate purpose-built architectures.
Which makes so much sense when you think about it.
It really does. We have the TPU-8T, which is built exclusively for training, and the TPU-8i, built exclusively for inference. Let's unpack the training side first, because the scale is, it's almost impossible to wrap your head around.
It really is.
The TPU-8T is the workhorse. Google says it offers 2.8 times better price to performance than their previous Ironwood chip. A single superpod can network 9,600 liquid-cooled chips together, delivering 121 exaflops of compute power. Broadcom reportedly helped design this silicon.
121 exaflops.
Yeah, let's pause on that word, exaflops. For the listener trying to visualize this, an exaflop isn't just a big number. It is a quintillion calculations per second. A billion billion.
Wow.
If every human on Earth did a math problem every second for 4 years, that is what this hardware does in one single second.
It is just staggering raw power. And the reason Broadcom's involvement is so crucial comes down to traffic management. When you are training a frontier AI model, you are feeding it petabytes of data over several months.
Right.
The bottleneck isn't usually the chip itself, right? The bottleneck is how fast the chips can pass that data to each other. The TPU-8T solves this by using what's called a 3D torus network topology.
Which sounds like something out of a geometry textbook.
It does, but functionally, it's quite simple. Instead of connecting chips in a straight line or like a flat grid, imagine a multi-dimensional donut shape.
Okay, a donut.
Yeah. The chips are connected in a continuous loop in multiple directions, so there are no dead ends. Data can flow around the network without ever hitting a traffic jam, which is absolutely vital when you are pushing that much information around a superpod.
Okay, so the TPU-8T is doing all the heavy lifting to build the model. But once the model is built, it gets handed over to the TPU-8I, which is designed purely for inference.
Right, the actual server.
Right. Inference is the actual running of the model. When you ask a question, the inference chip generates the answer. Google claims the 8i offers an 80% performance per dollar improvement.
That's a huge jump.
Massive. It uses a new network called BoardFly and pairs 288 gigabytes of high bandwidth memory with 384 megabytes of on-chip SRAM to prevent lag. MediaTek reportedly designed this one. But I want to focus on that on-chip memory. Why is having the memory physically on the chip such a game changer here?
Well, it all comes down to latency, the time it takes for a system to react. In standard computing, a processor usually has to ask the main memory for data, wait for that data to travel across the motherboard, and then use it.
Like a commute.
Exactly. It's a tiny delay, but it adds up. SRAM is memory built directly onto the brain of the processor itself. There is zero travel time. By keeping the active working set of an AI model entirely on the chip, you just eliminate the fetch time. In a world where an AI agent is reasoning through a problem and talking to 3 other software programs in real time to execute a task for you, latency is the ultimate enemy. You need lightning-fast reflexes.
So the on-chip memory provides that.
It does. It's the difference between a chef having all their ingredients chopped and resting directly on their cutting board versus having to walk to the walk-in fridge every time they need a pinch of salt.
Oh, that is a perfect analogy.
Yeah.
And it brings me perfectly to the analogy I was picturing for this whole TPU split.
Okay, let's hear it.
For the last few years, the AI hardware industry has basically been operating out of one mega restaurant. The chefs are in the back, sweating, trying to invent brand new, incredibly complex recipes from scratch,
Right.
while simultaneously trying to plate and serve thousands of hungry customers in the dining room at the exact same time. It's chaotic, it's expensive, and it causes delays.
And splitting the architecture fundamentally separates the building.
Exactly. The TPU-8T is the massive prep kitchen in the back. That's where the recipes, the models, are perfected over months of grueling work with massive ingredients. Then, once the recipe is absolutely perfect, they hand it over to the TPU-8I.
The front of house.
Yes, the 8i is the lightning-fast front-of-house staff. They aren't inventing the food. Their only job is serving the food to millions of customers simultaneously, as cheaply and quickly as possible.
The prep kitchen focuses on sheer volume and throughput, while the front of house focuses purely on speed and cost per plate, or, in the cloud business, cost per query.
But here is where I have to push back a little on Google's strategy.
Oh, okay.
If Google's new front-of-house and back-of-house chips are so incredibly powerful and cost-effective, why did they just sign a multi-billion-dollar deal with Mira Murati's Thinking Machines Lab to use NVIDIA's GB300 chips?
Ah, right. The NVIDIA deal.
Yeah, like Google is spending fortunes building custom silicon to take on NVIDIA, but they're also spending billions buying NVIDIA hardware to put inside their own data centers. If the TPU-8 architecture is the future, this seems totally contradictory.
I mean, it looks contradictory on the surface, but it really gets to the heart of the modern tech economy. You have to remember that Google is a cloud provider first.
Right.
NVIDIA still offers an incredibly powerful unified chip, and more importantly, millions of developers are deeply entrenched in NVIDIA's software ecosystem.
You're used to it.
Exactly. If a massive, lucrative customer like Thinking Machines Lab explicitly wants to train on NVIDIA chips, Google is going to provide them, because otherwise they risk losing that multi-billion-dollar customer to Microsoft or Amazon.
So they can't turn away a paying customer, even if the customer wants to use the competitor's oven, so to speak.
Precisely. But the deeper strategy is about the long game of inference. As these AI models graduate from the laboratory into the real world, where they are answering billions of queries a day for normal people, the unit economics completely flip.
It becomes all about the serving cost.
Yes. At a massive global scale, the cost per query matters more than almost anything else. By splitting their chips and optimizing the TPU 8i purely for low latency, low-cost serving, Google is positioning itself to be the cheapest, fastest place to actually run the models, regardless of where they were built.
Oh, I see.
Even if a company trained their model on NVIDIA hardware, Google wants them to serve it to their customers using the TPU 8i. They are playing a very specific game of margins here.
Okay, that makes a lot of sense. So Google is spending billions to optimize these 8i chips for instant, cheap reflexes. What does that actually look like when you or I sit down at our laptops?
That's the real question.
How does that massive, raw computational power change the 9-to-5 workflow of a busy professional or a parent trying to get out of the office on time?
Yeah.
Let's transition to Google's newly announced workspace intelligence.
Yeah, this is where the abstract world of exaflops and SRAM memory translates into tangible relief at your desk. Workspace intelligence is a new background context layer running across Gmail, Docs, Slides, and Sheets. It's all connected now.
Exactly. It is powered by advanced Gemini reasoning, making use of that fast inference hardware we just talked about.
And the most fascinating part of this is how it breaks down what Google refers to as context walls. Historically, your software has been deeply fragmented.
Incredibly fragmented.
Your email was totally siloed from your spreadsheet, which had no idea what was in your slide deck. But Workspace Intelligence acts as a foundational layer of situational awareness. It understands the complex semantic relationships between your active projects, your collaborators, and your broader company knowledge.
Right. It actively knows what projects you are assigned to.
Yeah.
It knows who your direct reports are. It knows the formatting templates your company prefers for quarterly reviews.
It just knows.
Yeah. And it surfaces all of that awareness through features like Ask Gemini and Google Chat, which essentially becomes a unified command line for your entire professional life. You can just type into chat, generate a slide deck for the Q3 marketing review. And instead of giving you a generic outline, it will pull the latest conversational data from your recent emails, grab the exact revenue numbers from your sheets, apply your company's specific visual style and logo, and drop the finished, highly specific presentation right into the chat.
It's amazing.
It can instantly triage your inbox to find the 3 emails that actually matter, or negotiate meeting times that work for 5 different people across 3 time zones.
And it goes even further by learning your unique work style, your voice, and your specific formatting preferences, ensuring that any drafted outputs sound authentically like you.
And this is exactly where I have to throw a flag on the play.
Uh-oh. What's the flag?
This concept has a major uncanny valley aspect to it.
Yeah.
The idea of an AI silently studying years of my emails so it can mimic my exact voice, I think a lot of people will find that deeply unsettling.
It is a little eerie.
Is it going to sound like a stiff robot pretending to be a human? How does a piece of software actually know my specific quirks? And frankly, do I even want it to? Having a machine impersonate my personality to my coworkers feels like a boundary violation.
That is a completely understandable reaction. The idea of digital mimicry makes a lot of us uncomfortable because it feels, well, invasive. But let's look at the real-world application here and frame it a slightly different way.
Yeah, I'm listening.
Think of it less as a robot stealing your identity and more like having a brilliant, highly observant executive assistant who has worked 10 feet away from you for 5 years.
An assistant who knows my habits.
Exactly. A great executive assistant knows that you always use a specific blue font for your headers. They know you despise long paragraphs and prefer bullet points.
Guilty as charged.
Right. They know that when you write a weekly update to your boss, you keep the tone strictly analytical and formal, but when you email the creative design team, a tone is much more casual and collaborative. Workspace intelligence isn't trying to capture your soul.
Well, that's a relief.
It is simply trying to save you the cognitive load of formatting and context switching. It's the ultimate time saver. Imagine being a busy professional who just wants to leave work at 5 p.m. to see their family, instead of spending 45 agonizing minutes reformatting a spreadsheet and drafting 6 generic update emails.
So it's less invasion of the body snatchers and more like autocomplete on steroids.
Yes, perfect way to put it.
It captures the repetitive mechanics of how I work, so I don't have to manually execute those mundane steps over and over again. If I always bold the top line of a memo, it just does it.
It removes the friction from your digital workflow. It handles the structural busy work so you can reserve your mental energy for actual decision-making and creative problem-solving.
That does sound significantly more appealing when you put it like that. So we've got the physical silicon providing the raw power. We've got the personal assistant layer helping you as an individual. But what happens when an entire enterprise decides to scale this up?
The fleet management side.
Exactly. If everyone has a personal assistant and the company decides to deploy thousands of its own autonomous AI agents, that's a lot of invisible hands in the cookie jar. We move from personal productivity to massive corporate fleet management. And that brings us to the launch of the Gemini Enterprise Agent Platform.
This represents a major evolution from Google's previous Vertex AI tools. It is a completely revamped developer platform designed to manage the full lifecycle of AI agent fleets. And fleets is the critical word here.
We're not just talking about one chatbot.
Not at all. We aren't talking about deploying a single customer service chatbot. We are talking about an interconnected workforce of software programs.
The platform allows developers to build, tune, and manage over 200 different models. You can use Google's own Gemini 3.1 Pro, Nano Banana 2, open models like Gemma, or even direct competitor models like Anthropic's Opus 4.7.
Which is great for flexibility.
Yeah, but the truly wild part is how developers can structure these agents into subnetworks, where agents autonomously pass tasks to one another without human intervention.
The demo they showed at CloudNext was a perfect example of this. They simulated a fictional furniture company where a team of software agents was working together. An inventory agent was continuously monitoring warehouse levels.
Right.
It noticed a massive surplus of a specific type of office chair. Without being prompted by a human, it autonomously delegated a task to a separate marketing agent, instructing it to spin up a targeted email promotional campaign to move that specific chair inventory.
Wow.
They collaborated exactly the way a human logistics team and marketing team would.
Which is incredible for efficiency, but it also introduces a massive chaos factor. Think about the risk here. You have autonomous agents delegating tasks to other autonomous agents, pulling sensitive data from company spreadsheets, drafting external marketing emails.
It's a lot of moving parts.
Without human bottlenecks to double-check the work, are we just one glitch away from a catastrophic security breach? What happens if a rogue AI accidentally attaches a highly confidential financial report to a client email because it misunderstood a prompt? How does an IT department sleep at night?
Honestly, security and governance are arguably the biggest hurdles to enterprise AI adoption right now, because the exact scenario you just described is every chief information officer's worst nightmare.
Right.
Google knows this, which is why they built something called agent identity into the very core of this new platform.
Cryptographic IDs sound like a highly technical way of saying a password, but at an enterprise scale, I imagine it has to be more robust than that to prevent a rogue scenario.
It is much more robust. The best way to understand agent identity is to think about how a secure office building operates. It is exactly like giving every single digital employee a corporate key card.
Oh, okay.
When a human employee swipes their key card in a corporate headquarters, the IT department and security team know exactly who entered the building, which elevator they took, which floor they went to, and whether or not they tried to access a restricted server room. Agent identity works the exact same way for the AI fleet.
So every action the AI takes leaves a digital footprint tied to its specific ID.
Every single action. It standardizes governance through a single control plane. The IT department has full real-time visibility. They can see exactly which databases an agent is touching, which other agents it is communicating with, and what external actions it is attempting to take.
And if an agent suddenly tries to access the payroll database when it's only supposed to be writing marketing copy, the system flags it. I imagine IT can revoke that access instantly.
Instantly. It provides the same level of strict line-by-line auditability that you would expect in a payroll system or quarterly financial reporting software. It eliminates the blind spots.
That's reassuring.
Furthermore, to prevent the rogue scenarios from ever happening in the first place, they introduced a tool called agent simulation.
So developers can put these agents in a sandbox before giving them real power.
Exactly. Before you unleash a new marketing agent into your live systems, you stress test it against complex real-world scenarios in a heavily monitored simulation. You watch how the inventory agent and the marketing agent interact, you try to break them.
You find the flaws first.
Right. You ensure they follow the rules before you ever give them the actual keys to the company email server. It ensures that the transition to a hybrid human and AI workforce is secure, heavily monitored, and fully auditable.
That keycard analogy really clarifies the mechanism. It isn't a digital free-for-all. It's a highly regulated assembly line of software. Well, we have covered a massive amount of ground today, tracing the path from the physical hardware all the way up to corporate governance. But before we wrap up and connect all these dots one last time, let's hear from our final sponsor.
Before we wrap up, a quick thanks to Old Glory, an iconic music and sports fan merch store. Perfect for the techie in your life. Use promo code SNARFL for 15% off at oldglory.com.
Let's take a step back and look at the entire journey we just took. We started all the way down in the engine room with Google's physical silicon, the new TPU 8T and 8i chips.
The foundation of it all.
Exactly. The architecture of AI is splitting into two purpose-built lanes. You have one massive prep kitchen dedicated to training the models with zero traffic jams, and one ultra-fast front-of-house staff dedicated to serving the models to keep inference costs as low as possible.
And that raw, low-latency compute power is the foundation that makes tools like Workspace Intelligence possible. It provides the sheer speed necessary for an AI to act as a seamless executive assistant right on your laptop.
Understanding the semantic context of your daily work.
Right, remembering your formatting quirks and saving you valuable hours of repetitive busy work every single week.
But once you scale that personal assistant concept up to a massive corporate level, you require serious oversight. That is where the Gemini Enterprise Agent Platform comes in.
The management layer.
Right. It acts as the IT control plane, using cryptographic keycards to ensure that massive fleets of autonomous software agents can collaborate securely without causing digital chaos or compromising sensitive data. It really is a complete top-to-bottom stack, from the physical silicon to the desktop software to the enterprise security.
It is a profound paradigm shift in how human labor and computational power intersect.
It is. And it leaves me with one final thought to mull over. As these AI agents become increasingly sophisticated, as they become capable of monitoring global inventory, designing complex marketing campaigns, and autonomously delegating tasks to other AI agents within these subnetworks.
It gets wild.
It does. At what point does the organizational chart of a Fortune 500 company feature more software programs than human beings? And when you are managing a team that is 80% cryptographic IDs and 20% human staff, how does that fundamentally change the very meaning of being a manager?
That is an incredibly complex question, and it is a reality we will all be navigating very, very soon.
Something to think about as you head into the office today and swipe your own keycard. We're here to help at Snarful, so reach out on our website if you have any more questions.
That's a wrap on today's top stories. Remember, tech doesn't have to be complicated, and we're here to help connect the dots. If you've got questions or want to learn more, visit us at snarful.com. Thanks for listening, and we'll catch you next time.